In this question, we have to find a relationship of x and y. There isn't a lot of information mentioned in the question premise, so we can start working with the individual statements. However, before we go in there, let's quickly look at what the question wants us to find. So the question asks us that if x or is x greater than y, which means that if we plot x and y on a number line, the question wants us to kind of find out whether x lies to the right of y on a number line. Now, that's the only information that is given, so we can start we can start working with the individual statements. So the first statement tells that under root of x is greater than y. Now the first thing that we can sort of notice is this particular part, under root of x, which means that in this case x is always kind of non-negative, because under root of a particular value is always non-negative, right? Now, so this in a way helps us kind of narrow the regions of the number line that we need to work with. So I'll kind of draw a number line, and because we are only dealing with a non-negative region, this is a region of focus. Now let's say x lies in here, right? This is the position of x. Under root of x would be a value which will lie to the right of x, right? So it'll have a value greater than x, but it will not exceed 1. So it'll be the value of under root of x will be between 0 and 1. So let's say this is the value of under root of x, and the question says that the value of under root of x is greater than y, which means y can either be here or it can be here, right? Y can also be negative, but I think this region itself is enough to prove that this particular statement is not sufficient. However, so that we look at this entire segment of the number line more holistically, let's look at the region in which x is greater than 1. So if x is greater than 1, let's say x lies in here, under root of x is a value which will lie to the left of x, which means under root of x will be a value which will be less than x. And the statement tells us that the under root of x is greater than y, which means y will lie in here. Again, y will lie to the left of under root of x, and it can also be between 0 and 1. In a nutshell, if x is between 0 and 1, y can either lie to the right of x, as in this particular combination when x is here and this is y, or y can lie to the left of x. If you look at this particular combination, y can be here. So this statement alone is not sufficient to conclusively tell whether if x lies to the right of y. In some cases yes, and in some cases no, so we can strike off a and d, and the answer will either be b, c, or e. Now let's look at the second statement. The second statement tells x cube is greater than y. Now because it's x cube, we no longer can restrict our analysis to the positive side of the number line. So I'll probably create a wider segment in which we will evaluate the four sections of number line, in one in which x lies between minus infinity to minus 1. The other section is where x lies between 0 and 1. The third section is in which x lies between 0 and, sorry, this is positive 1. And the fourth section in which x lies beyond 1 and towards infinity. So let's start looking at this section first. So let's say if x lies here, x cube will be a value which will lie to the right of x. The value of x cube will always be greater than x if x is beyond 1. Now this statement says x cube is greater than y, which means y lies to the left of x cube. So y can either lie in here, or y can lie in here, or y can lie in here, or anywhere here, right? But if you look at this region again is it's sufficient for us to tell that this statement alone is not sufficient, because in some cases we have y we have y lying kind of to the right of x, and in some region y lies to the left of x. So we can strike off B. Again, just for the sake of discussion, I'll also look at this particular region, because I know that B is not sufficient, so I have to go and do C and E. So let's quickly look at the other region as well. Now, if x lies between 0 and 1, x cube will be a value which will be lesser than x. So x cube will lie to the left of x. And the statement says that x cube is greater than y, which means y can either be here or y can be a negative value. So if x lies between 0 and 1, we know that the value of x cube, sorry, the value of x is always greater than y. But in any sense, we have already proved that this statement is not sufficient. So we'll move to C. Now the statements combined, let's see what information it gives us. So again, because we have a root x here, our analysis will only be limited to the, the non-negative section of the number line. Now the first statement tells that root of x is greater than y. So again, we'll just quickly plot x, root of x, and it also talks about x cube. So this is x cube, and it tells us that root of x is greater than y and x cube is greater than y, which means the only possible value of y is here. It cannot lie anywhere else because it has to be less than x cube. What about this section? So let's say if x is here, x cube is a value which is to the right of x, and root of x is a value which is to the left of x. The statement tells us that root of x is greater than y, which means y lies in here, but it also tells us that root of x is to the right of y. Okay, so y lies in here, and it also tells us x cube is greater than y, which means again y lies in here. So in both cases, either y lie in here or y lie in this particular region. So in a nutshell, in both the regions, y lies to the left of x, and we can say that x is greater than y. So the statements combined helps us to arrive at a definite answer, that is x greater than y. The answer is yes, and the correct option to the question is C.